right, you guys, we're going to talk about graphs of transformed sine and cosine functions today. It's going to, as usual, it's just going to be a lovely time. Um, let's just move back a little bit and talk about sine and cosine really quick. So a couple things about these functions. So y equals the sine of x. If I were to graph y equals sine of x, right, we know we know that the y-axis doesn't look like that. We know that, sine goes through the origin, right? Because the sine of 0 is 0. It goes up to 1 at pi over 2, comes down to -1 at 3 pi over 2. And then remember, it's an odd function. So it's reflective about the origin, meaning that if I took the sine of a negative x, I get a negative sine of x. So that's sine. Cosine is very, very similar. These functions should be similar, right? We know that they have a lot of similarities in terms of, the sine of 30 is the cosine of 60 in terms of complementary angles and stuff. So cosine, remember, doesn't start at the origin. Cosine starts up at, these are not perfect waves. I feel like I say that a lot in my lectures and about how these things aren't perfect. Okay, so this is the cosine wave and the sine wave, similar to that. And let's just talk a little bit about some stuff about both of these functions. So both of these functions, the domain of each function is -infinity to infinity, right? We talked about that. The range of these functions is -1 to 1, including the -1 and the 1. And then a couple other things. This idea of something, I kind of alluded to this in the last lecture, but I want to talk about amplitude. So amplitude, the definition of amplitude is if you take the maximum value, add it to the minimum value, and then divide by 2, that is our amplitude. But what I want you to think about it is basically the amplitude, if I cut this graph in half, it's the distance that I would go above that line and the distance I would go below that line. Okay, so if I could take that wave and basically slice it horizontally. Same thing with cosine. It's going to be that maximum distance above and that maximum distance below. Okay, that's what we define our amplitude to be. It's a distance, so our amplitude for both of these is 1. Okay, the other thing that we kind of talked about was we talked about how these functions are periodic, meaning after a certain distance on the x-axis, it starts repeating itself. So if we look at sine, right, it's the distance it takes to go through all the range values before it starts repeating itself, and that's what we call one cycle. So notice here I'm starting at 0, so I'm going to go up. I come back down to 0 again, but I haven't gone through any of my negative values. So I need to go through my negative values. And now when I come back to 0 again, notice I've hit every value between -1 and 1. So in one cycle, what has that gone through? This is pi over 2. This is 3 pi over 2, right? That's pi, and that's 2 pi. So the period of this function is 2 pi. Same thing with cosine. If I start up at 1, coming down to 0, going all the way down to -1, and now I have to come back up and hit 1 again, right? So that is going to be one cycle. And again, that's 2 pi, right? Because it's 0 at pi over 2, it's a -1 at pi, it's 0 again at 3 pi over 2. So we say that the period of this function then is 2 pi. Okay, so these are some things about sine and cosine that are kind of important to realize. We're going to talk about what happens if we mess with them, right? That's what we mean by transformed functions, is I want to know what's going to happen if I just kind of do stuff to this. Like, what if I take sine and I add 4 to it? Or what if I take cosine and I'm going to take 5 times the cosine of x instead of just the plain old cosine of x? I know you've been wondering the same thing. So today you get your answers and you will sleep well tonight. So let's consider something like, let's start off kind of easy. Let's consider the function y equals, now I'm going to kind of develop the idea of a couple of these and then I'm just going to graph them on Desmos for you, okay? And so you can see that. So when it comes to what you're going to have to graph, you will need to be able to graph sine, cosine, and tangent by hand without the use of a calculator. After that, any other graphs that I ask you to do, you'll either have your calculator or I might not actually ask you to graph it. I might actually tell you here's the function. Tell me how this is the graph of sine but transformed, and we'll do some examples. So let's look at cosine of x plus 2. So whenever, a lot of times in mathematics, if we don't know what the graph looks like, and if we don't have a calculator, some things we can do is we can just plug in values, right? So let's start with x. What if we're at 0 degrees? Well, the cosine of 0 degrees is 1, and if I add 2 to it, we'll be actually up at 3, right? So, and if I asked you, what do you think this is going to do, the graph of cosine, if you were here hanging out with me and I wasn't all alone by myself in my office, you would probably, I need to rethink this because I do know what's going to happen here. You would probably tell me, well, based on what I know about transformations of functions when we had so much fun. Remember how much fun we had in, 3, 4, 5. Okay, remember how much fun we had in college algebra? I know. I had a good time too. You know some things about what happens when I add numbers, right, to these functions. So let's humor me. Let's go through this. So cosine of 0 is 3. If I look at the cosine of, let's say, 60 degrees, right, or pi over 3, I chose that because that's 1/2. So if I add 1/2 to 2, that's about 2.5. Not about, it is. Let's put in pi over 2. So pi over 2, or 90 degrees, the cosine of 90 degrees is 0, so we're going to be at 2. Let's just jump to negative pi, not negative pi, Sarah. Come on, pi. Cosine of pi is a -1, and a -1 plus 2 is 1. I'm going to just jump to 3 pi over 2. I know this guy's going to do the wave action, right? So 3 pi over 2 is 0, 0 plus 2 is 2, and then finally back at 2 pi, cosine of 2 pi is 1, and 1 plus 2 is 3. If I went too fast there, pause the video and verify for yourself that you agree with all of these values that I got. So let's, there's my 1. Pi over 2 is just a little bit bigger than 1. So I'm going to make that distance just a little bit bigger. And I haven't considered negatives yet, but I think once you see kind of the pattern, we can imply what that's going to do here. Okay. So at 0, now instead of starting at 1, my function cosine is going to start up at 3. At pi over 2, well, pi over 3, which is just 1/3 of the way to pi over 2, 2/3 of the way to pi over 2, I'm at 2.5. So I'm going to actually come down just a little bit. At pi over 2, I'm at 2. Okay. At pi now, I'm going to be down at 1. Okay. And then at 3 pi over 2, I'm back up at 2. Whoa, come on, Sarah. Back up at 2. And then at 2 pi, I'm back up at 3. Okay. And now cosine, remember, is an even function. So what that means is, even when I put in negative pi, I'm going to get the same thing out that I would get out for pi because it's an even function, meaning it has symmetry about the y-axis, and the negative doesn't really matter. The cosine of a negative number is the cosine of that same number, but positive. So that I'm going to use to my advantage. Again, that means it's an even function. And that will be, if you can kind of understand those even and odd functions when you get to calculus, sometimes that saves you a lot of time. So like at pi over 2, I'm at but 1. So that means I know at negative pi over 2, I'm at 1. That was not great. What's going to happen at pi? I think after this one, we'll be at 1. We'll just graph this on Desmos. Oh yeah, that's not great, but whatever. Negative pi, and then at negative 3 pi over 2, I'm back up at 2. So here's what's going to happen. We're going to get something. I know that the graph of cosine is this nice wavy looking thing, right? And so here's what. Oh, that's not that great. I think I made these a little bit bigger than what I had over here, but you get the gist of this, right? So if I look at cosine, remember, started at 1 and then came down and had a period of 2 pi, right? So clearly that's off right there. But what has just happened to the graph of cosine when I add this 2 to it? And it's exactly what we should think happened, right? When we used to deal with x squared, we know the graph of x squared is a parabola that goes through the origin. What would happen if I took x squared and I added 2 to it? That would just move it up 2. And that's what's going to happen here. So a couple things here. Let's see what this has changed. So the things I'm going to want you to state. I'm going to want you to state the amplitude. The amplitude on this, okay, if you cut this guy in half, right, look at this, it's still going to be 1. Okay, so taking that graph and moving it up 2 doesn't change the amplitude, and that kind of makes sense. The period on this is still the same. I haven't changed anything with how long it takes for me to complete one cycle, right? That is going to still be 2 pi. But there has been a translation, and what I'm going to have you do is state all of those translations. So what is going to happen here is we are going to have a shift or a translation up 2. Okay, domain stays the same. Range is a little bit different now. You know, if I'm moving up to, remember my range was -1 to 1, and if I'm moving up to, now my range is going to be 1, 2, 3. Right? The lowest I get is 1, the highest I get is 3. And that's kind of how that works. Isn't that neat? So I want to do, okay, I said I wasn't going to do one more like this. I want to do one more like this. I'm going to do sine, and then what I want us to look at is I want us to, we'll kind of tie this, put this all together, and I'll just show you some pictures in Desmos, and then I'll show you kind of how to do this with your calculator. But your book kind of takes all of these things that it figures out and puts them in all these different boxes. But what I'm going to do is I'm just going to put it all together. And they have a nice box of that in your book too. All right, so let's consider something like y equals the sine of 2x. Okay, so instead of adding that 2, which by the way, if I had subtracted that 2, that would have just taken my graph and moved it down 2. But let's look at the sine of 2x, because this one is not quite as obvious. Okay, so we didn't really we dealt with multiplying by things, but it didn't really, not in the same way as this. So let me just stop talking and let's do it. Okay. So what is the sine of 0? The sine of 0 is 0, right? So that guy is going to stay the same. And let me kind of get my graph here. Pi over 2. Pi. Give myself a little bit more room. 3 pi over 2. I want to do at least one period. I don't know if my period is going to stay 2 pi or not. So I might need more. I don't know. I might need less. Negative pi over 2, negative 3 pi over 2, negative pi. I'm sorry, negative pi, negative 3 pi over 2, negative 2 pi. And then, you know, my 1 is going to be just a little bit smaller than pi over 2. Pi over 2, remember, it's about 1.57. So when you're like making your own here, I don't know, think about that. All right, so sine of 0 is 0. So my new function here, I know I'm going to go through, I know I'm not going to go through that point. That is what I know, that is not 0, 0. I'm going to go through 0, 0, so that's not going to change. But let's kind of think about what's going to happen here with the 2x. I'm going to put in, because I'm going to be taking this angle and multiplying it by things, let's go ahead and put in pi over 4. And I kind of know what's going to happen. So I'm choosing pi over 4 for a reason. So that would be the sine of 2 times pi over 4, right? Which is the sine of, pi over 2. And what is the sine of pi over 2? It's 1. So now instead of hitting 1 at pi over 2, I am hitting 1 sooner. I'm hitting 1 actually at pi over 4, which is halfway between there. What about pi over 2? What if I put in pi over 2? This is kind of cool. I mean, I know what's going to happen, but I still just love doing it. The 2's cancel. I get the sine of pi. The trig, you guys, is so cool. And then I'm at 0. So before sine, right, would hit 0 when it was at pi, but now sine is hitting 0 at pi over 2. God, this is so exciting. All right, let's put in pi. Okay, so sine of pi. So 2 pi. That would be actually 2 times pi, right? Because I'm plugging pi in for that x right there. Well, we know the sine of pi is 0, but now we're seeing that the sine of 2 pi, that's 0 also. So it looks like I'm skipping a point right here. So I know I'm going to be right here. Let's see in between there. Let's pick a number in between pi over 2 and pi. So how about 3 pi over 4? So 3 pi over 4, if remember where 3 pi over 4 is, that's pi over 4 away from pi. So there I am picking a number between pi over 2 and pi. So if I take 2 times 3 pi over 4, my 2's cancel, I get sine of 3 pi over 2, and that's my -1, which is what we should expect to happen here. Sorry, they're moving a cart apparently with like horses on it or something outside of my office. All right, so look at what's happening, guys. This is kind of exciting. So now you can kind of see my dots here, and I will tell you, and I'm gonna just, I hope you trust me, that sure enough, look at that. I have done one whole cycle of this guy. Sorry, that's so small. I've done one whole cycle of sine now in pi. And now look at what's going to happen again. If I put in, so I have pi over 2 pi, 3 pi over 4. If I put in 3 pi over 2, right, the sine of 2 times 3 pi over 2, my 2's are going to cancel and I'm going to be at 0. So let's find 3 pi over 2. That's pi. 3 pi over 2 is going to be right here. And you're going to see if I had put in, you know, if I had put in 5 pi over 4. Sorry, I'm doing purple now. Sine of 2 times 5 pi over 4. That's the sine of 5 pi over 2. So let's see where 5 pi over 2 is. So that's pi over 2, that's 2 pi over 2, that's 3 pi over 2, that's 4 pi over 2, that's 5 pi over 2. So sure enough, that's going to equal 1. So in between there, I'm going to be 1. So if you notice, I've just started repeating again. Okay, and because sine is an odd function, right? This 1 right here, when I bring it over here, is going to be negative instead of positive. My zeros are going to stay the same, but I'm going to have the opposite sign, S-I-G-N. So that's one way to maybe remember sine is odd, is that the sign is different in the sign. Ah, that was kind of dumb, but... So guys, there's sine of 2x. I want to show you sine itself, right? Looks like this. So this is sine in the yellow. Not a great one, but you know, I'm trying. Not very hard, clearly. Anyway, so what has this done? If you've noticed, what this has done is it's taken sine, which is the yellow curve, and it's just squished it. So it's just like shrunk it like an accordion and made it actually kind of go a little bit faster. So in terms of stuff that we describe these graphs with, what's the amplitude? The amplitude has not changed. It's still going from -1 to 1. But what has changed is the period. If you notice, it takes... Look at the period here. It's done one whole cycle in just pi. And we're going to write this down. I'll show you that this is true. The period is pi, and the way that we find that is we take the period of sine, which is 2 pi, and what we're going to do is we're going to divide it by whatever that number is in front of x. Okay, and we'll just kind of state that. And I know that's not really a proof, but I've shown you an example of it. Amplitude is 1. Period is pi, meaning I do a cycle in a shorter amount of time, so it's kind of going faster. So anytime your period is smaller, it means you're going to get a little bit faster of that wave. If my period was like 4, it means it's going a little bit slower, okay? So it's a little more lazy. So I would, you know, if I were to describe my personal time to go through that, I would have a longer one. Because I would go a little bit slower probably. Amplitude, what else was there? Were there any shifts or translations? No, the only thing that happened was it was squished, right? But you could call that a translation, but I have no shifts up or to the left or to the right, anything like that, okay? Cool, huh? So what I would like to do now is I'm just gonna actually, I'm going to write down kind of all of these rules, and then we'll see why these rules are true. I want to show you some more graphs. I'm not going to develop them by hand like I have been doing just now, but we'll do them with the graph. So let's write down kind of some of these rules, and then we'll look at the graph of them. Okay, so transformations of sine and cosine functions. So let's look at so a couple things here. I need to think about all the possible things that we could do to sine or cosine. So y equals, so here's some things we can do to sine or cosine. I could take sine or cosine and I could multiply it by a number in front of it. And what we're going to see that does is that's going to change the amplitude. If you think about that, you know, if I graphed 3x squared, remember that's just a parabola, it's just stretched out a bit. That's exactly what's going to happen here. That a can be positive or negative. If it's negative, it flips it across the x-axis. We remember these, right? If it's positive, it doesn't. So let's say I have a times sine. So what are all the things we could do to this function? I could take x and multiply it by a number, right? And then I could even add or subtract things to that x. So this is all the possible things I can do. And then if I really wanted to, I could add or subtract a number to the graph of sine. So let's think about what all of these things are going to do. So remember something like x squared plus 4, that's a shift up. Whereas if I had x squared plus 4 inside the parentheses, this is actually a shift to the left. That's what we're talking about right here. And remember, we put the negative sign so that it's the opposite direction of the sign. So this will tell us it's a shift to the right. So this is going to be what I have. The other thing that we're going to look at, and I'm just going to rewrite this, and then I promise we're going to do examples. I'm not just going to leave you hanging here. If I factor that b out, that's actually going to tell me what horizontal shift I have done. So remember this c right here, if that b is a number that isn't 1, I haven't actually shifted it by c. What have I actually shifted it by? Well, I have to factor that b out because I want to know, and again, we'll do examples. I want to know what's the number I actually am taking away or adding to x. So this is just why we're going to write it like this. And this is true for cosine also. So cosine, remember, you don't have to have all of these numbers. This is just considering all the possibilities that could happen, right, with these values. And so let's write down all the stuff that's going to happen, and then we'll look at a bunch of examples of this. Okay, so when we have this, I'm going to do this in the order in which it does it. So I'm going to kind of copy your book. So the first thing that we have to think about, if we plug in an x value, what's the first thing we're going to do to x? We're going to multiply it by b. Okay, so this is going to shrink or stretch horizontally. Okay, so if b is not 1, okay, that's what b is going to do for us. It is going to stretch or shrink us horizontally. So if the absolute value of b, it doesn't matter if it's positive or negative, but if the absolute value of b is less than 1, this is going to be a stretch. So think about, I'll show you this. If b is greater than 1, so remember our period is going to be that 2 pi over b. So if b is less than 1, then it's going to make that 2 pi bigger. So remember, it's going to make it lazy. If it's bigger than 1, then it's going to be a shrink horizontally. Okay, and then if that b is less than 0, that's going to reflect about the y-axis. Now all of these you don't have to tell me. When I ask you for these, for like what this stuff is doing, what I'm really going to want from you in terms of b is just, what's it going to do to the period? And that is what I care about. So now this is the big thing, is that if you have a number in front of x that is not 1, then it's going to change the period. And I'm just putting absolute values in case that b is negative, but you just take the regular b, okay? So that's my period for the function. And that's the big thing that I want you to take away from what b does to the graph, is it changes my period. Just like that sine, when I had sine of 2x, remember that took my period and that actually made it smaller, right? 2, okay, so that's what that b is going to do. Then what else is going to happen? We're going to have that a. So that's going to be a stretch or a shrink vertically. Okay, that's what a is going to do for us. Ooh, I'm not going to be able to put all this, so I may have to put this together. If the absolute value of a is less than 1, that means it's a fraction between -1 and 1. That's what that's saying. Then we have a shrink vertically. And we already said vertically, so I'm going to just leave that there. That makes sense, right? If I had graphed 1/2 x squared, remember that's a shrink. If absolute value of a is greater than 1, that's going to be a stretch. It's going to stretch that wave. Okay, and then the last thing here, if a is less than 0, then we reflect the x-axis, right? If it's negative. I'll just put reflect x. But the big thing that I want you to know from this one is that the amplitude, then in this case, is the absolute value of a. Okay, so that changes the amplitude. That changes how high and low it goes if you cut that guy in half. Okay, we're getting pretty close. I really want to fit this all on one screen. So 3, what about so now we're talking about like our shifts. So here are the things I'm going to ask you for period and amplitude, and then any shifts and translations. So the shifts is what I'm talking about, and that's that CB. So we're going to have translation horizontally. I don't know if I'm going to be able to fit this. That makes me so sad. This is going to be that C over B. I think I'll fit it right here, and then we'll put number 4 over here. So if CB is less than 0, right, then we shift. So look at, if CB is less than 0, right, then this becomes a plus sign, and we shift to the left. Okay, if C over B is greater than 0, we go right. And again, that's because if CB is greater than 0, then that negative stays. So I don't want you to think about this so much. What I want you to just think about is if it's positive, it goes to the left. If it's negative, it goes to the right, meaning this sign in the middle right here. If it's positive, it goes to the left. If it's negative, it goes to the right. Go away. There we go. Okay, and then number 4, what's the last thing? This capital D right here, what does that guy do? That translates vertically. Right, that tells me to go up or down. That translates vertically. And so if D is less than 0, we're going down D units, right? Absolute value of D units. I hope that makes sense. If D is greater than 0, we're going up the absolute value of D units. So these are the things I want to know. I want to know how do you translate horizontally? If you translate vertically, what is the amplitude and what is the period of the graphs if I give you one that has a bunch of crazy stuff going on. Okay, so let's do don't want to get rid of that yet. So let's do a couple examples. So for example, I'm going to do example, and then all of these we're going to do this. I want you to state the amplitude, period, and then I'm going to say phase shift, because that's the horizontal shift, okay, that's what they call it. So basically I'm just asking you, and any vertical shift, basically tell me everything of the given function. And I'll be a little more intentional on how I'm going to state this. So I'll say something like, state all of this stuff. What is the difference in all this stuff from like sine or cosine? Okay, so let's look at something like y equals 3 cosine of x minus pi. Okay, so 3 cosine of x minus pi. So if I look back at what I've been given here, I have a couple things here. I have this a is different. Oh, yeah. And I have, I don't know how that became a positive right there. That should be a minus. And I have a phase shift, right? I'm taking away. So let's look at what I'm going to have here. So let's state the amplitude. So remember, the amplitude now is just going to be, it's just going to be now that number, because what that's going to do to cosine, you guys, is it's going to take every value of cosine. So there's my beautiful cosine, that's at 1, and it's going to take those values and multiply it by 3. So now instead of 1 being at 1, 1's up at 3. Instead of negative 1 being at 1, 1 is down at 3. So I might have something like this. That's beautiful, Sarah. Really good job. But that's what it does to the amplitude without that shift there. Let me get rid of that. I can't look at that anymore. So here are the things that's going to happen, and then we'll look at what does this look like on our calculators. We'll just probably use our calculator. All right, so what do we have here? The amplitude then is going to be 3. The period, what is my period going to change? It's not, because I have just a 1 in front of the x. So 2 pi over 1 is just still 2 pi. So it'll just take 2 pi to get through a cycle. The phase shift. So my shift to the left or right, I want you to tell me which direction. I'm going to be going to the right because it's negative. I'm going to be going to the right pi. And then there's no vertical shift for this guy. Okay, so I want to show you how we can graph that. So that's pretty much all for this one. Of course, we're going to get more complicated. But, all right, this is brought to you apparently by Apple. And I don't have any, I don't think I'm allowed to say that. My computer's in the background. Okay, so let's look at how to graph this. So go ahead and turn your calculator on, obviously, and let's get y equals, let's put in 3 cosine of, and then just take x minus pi, okay? And I would also want to graph, let's just go ahead and graph the cosine of x as well, okay? And I might change that to be a little bit different. So let's have that guy be maybe a dotted line. There we go. All right, and so I'm going to go ahead and just graph. I don't know where I'm at with my window. Clearly, I'm not a window that's going to be useful to me. There's our cosine. Oh, it didn't change it, but that's okay. And so if I go to zoom, let's go to zoom trig and see what happens. So number 7, let's go to zoom trig. So, okay, perfect. There's my 3 cosine of pi, x over pi, and there's my cosine. So as you can see, my amplitude clearly has changed. We're now up at 3. Here's my cosine, right? And if you see that peak right there, it has been shifted over pi. This is pi over 2, and this is pi. The great thing about zoom trig is if you look at your window, this goes from negative pi over 2 to negative 2 pi to 2 pi. And then this 1.707 is saying we want a tick mark at every pi over 2. So zoom trig is the best. I love zoom trig. So again, this short one here is my original cosine function, and then we've just kind of messed with it, right? We've shifted it over pi over 2. Notice how that peaks come over, pi, not pi over 2. And then we've changed the amplitude by multiplying by that 3. I hope that makes sense. Let's do another one because that was fun. Okay, so let's look at one that's a little bit maybe more interesting. So what if I had y equals negative 2 sine of 3x minus pi over 2. Now this one's going to be a little bit crazy when we actually graph it, but I just want us to talk about how we determine all of the things that I want you to determine. Okay, so here's what we know. We have that 2 in front. So the amplitude, it's not going to be a negative 2 because you want to think of amplitude as a distance. It's just going to be a positive 2. Okay, and now what I'm going to have to do, another thing I could look at just right away by looking at this is that my period is going to be 2 pi divided by whatever that number is in front. So that's going to be 2 pi over 3. So that means that I'm going to complete a whole cycle of sine in 2 pi over 3, meaning it's really going to squish it. Okay, now I got to figure out my shift. So notice my shift left or right is I want to know what am I taking away from my x value. And in this case right now, you're taking pi over 2 away, but you're not taking it away from x, you're taking it away from 3x. So what you need to do is you need to factor that 3 out. I need you to remember also that factoring is division. So when you take that 3 out, you are dividing x by 3 and you're dividing pi over 2 by 3, or think of it as multiplying by a third, and you'll see that we actually get pi over 6. Okay, again, if that confuses you, you need to let me know. If you take that 3 back through, you need to get pi over 2, and that 3 would cancel with the 6 and give you 2. Again, factoring is division, or you can think of it as multiplying by 1/3. Okay, so by taking that 3 out, now I see that I have a shift. Again, it's to the right because apparently I'm unoriginal. I didn't think about switching it, but what is my shift? It's pi over 6. Okay, so that's everything I want to know. Is there any vertical shift? No, there's not any vertical shift to that. That's my amplitude has changed. What's some other stuff that happened? Because that's a negative 2, I have flipped the graph of sine. It's been a reflection about the y-axis, but let's just look at what this is gonna, oh, Sarah, come on. Sorry, every time. Oh, and there you can see my breakfast burrito. I haven't eaten breakfast yet. All right, so here's what we got. So I'm going to go ahead and put in -2 times the sine of 3x, right, minus pi divided by 2. Okay, and let's go ahead and graph that and kind of see what happens. Yeah, so see how it's been kind of, it's an accordion a little bit that's been kind of pushed in, right? So my period is now 2 pi over 3. It has been flipped. It's hard to see that flip because we've also shifted it by pi over 6. But that's what my graph is going to look like based on the transformations that were given. Let's do just a few more and I think we'll call it good. Okay, this one looks kind of interesting and I like it. Let's look at 1/2 of the cosine of, I'm copying this from your book because I think it's interesting. 2 pi x and then all minus 1. Well, it's close to what your book is doing. So, sorry, I need to shut my door there for a second. What are we going to have here? A couple things. So I'm going to have, what do we know? This number right here, right? I know that the amplitude then is going to be 1/2. So we're just kind of cutting that in half. And then some things that I like about this is what's the number? So there aren't parentheses here. So the number in front of x is 2 pi. And so what is my period going to be? It is still going to be 2 pi divided by 2 pi, right? Which is just 1, the number 1 now. So it does a whole cycle in the distance of 1. And then notice there aren't parentheses here, so there's no shift left and right, but we have done a shift that is going down 1. Okay, guys? And you tell me which direction it's going to go. And that's it. That's all that's really been changed with that one. And then let's just do one more, and then I think hopefully it makes kind of sense, and we'll call it good. What was that? A, B, C, D? Are we on D now? Probably. What about if I had y equals a -5 sine of 1/3 x minus pi. 1 minus pi plus, let's get crazy, 4. This is going to be one that is kind of on a bit of an overachiever. So what does that 5 do, right? That changes my amplitude. So my amplitude is now 5. Let's look at my period now. My period is going to be that 2 pi divided by 1/3. So basically we're asking how many thirds, right, are in 2 pi. So remember, you flip that denominator and multiply, so that's 6 pi. So remember, this is kind of a lazy sine function. It's going to take a lot longer for it to get through one period. It's going to take 6 pi to get through one period. And then let's look at the shifts. If I rewrite this, this is a -5 sine, and I factor out that 1/3, right? Remember, factoring out is the same thing as division. So dividing by 1/3 is the same as multiplying by 3. So when I factor that out, that's actually going to be -3 pi. Again, if you're ever in doubt, just look at, if I take that 1/3 back through, right, I better get pi back out. So my phase shift, so I have a couple shifts, right? I'm going to have a shift. It's a negative again. Let's make that positive, so it's just different. I'm going to make that positive. It's going to be a shift to the left. And how far left are we going to go? We're going to go left by 3 pi. And then what's another shift that we have? I guess we don't need to write it again. So we're going left 3 pi, and then another shift we're going to go up 4. And again, all of these I'm going to go ahead and let you graph these. You can graph them on your calculator, you can graph them on Desmos. I recommend, graph it and see what happens, but I'm not going to have you do these by hand. You know, it's nice to know sine, cosine, and tangent because it's good to know what the graphs really look like. So in calculus, or later on when we start talking about the inverses of these functions, it's nice to know what they look like. When we get to the transformations, I realize you guys have graphing calculators, you have Desmos, you have ways to graph these without having to do it by hand, okay? So if you have any questions about this stuff, just let me know.